everybody. My name is Ken, and today we are doing our first inaugural episode of Talk 3D. It's going to be a podcast that we are putting together so we can tell you what's relevant in the industry, as well as what's relevant with us at the shop. So today I have with me Felix. Felix, how are you doing?
I'm doing good. I'm excited.
Good. What do you do, and why do we know each other?
Why do we know each other? Well, I work at Shop 3D, so that's how we know each other. But I'm the senior application specialist here, so I answer any tech questions and I help people find out, what they need to make whatever it is they want to make.
Exactly. So when I have things I don't know, I ask Felix, and it's his job to know or find out.
Or find out, yeah.
But
I know everything, right?
Exactly. So awesome. I want everybody to know how cool we are at Shop 3D because all we do is talk about 3D things all day long, and that's our passion.
Yeah.
And we know it's the passion of some of the people out there. Mm-hmm. So that's why we wanted to do this kind of format to share things that we want to talk about, as well as things that we've been experimenting with, sure. Especially during this time when we can't have a lot of people, around us. This is one way that we can kind of express ourselves and share. So you've got some topics that you want to talk about today. So do you want to get started on that?
Let's do it.
Okay.
What's
first?
So first, I want to talk about quality control in 3D printing.
Okay.
And specifically, machine learning and AI in that. So,
of course, a very technical subject from you.
Yes. Of course, it has to be.
Let's do it. Let's do it.
It has to be. So. There's a big problem, well, not a problem, but a concern, let's say, in 3D printing is that how do we inspect parts? Is it a visual inspection? Are we measuring these parts? 3D printing is a simple process, but it can become really complex when you sort of, you put a microscope over it.
Does it get more complex if we simply call it additive manufacturing versus 3D printing?
Yes. Yeah. Like exponentially, just 100 times, just way more complex. Additive manufacturing is. It
seems like you move up a tier when you say it's from 3D printing to additive manufacturing.
Yeah.
It's a joke, but it's true.
People think 3D printing is for hobbyists, but additive manufacturing is for the big boys.
Yeah, exactly. If you're an engineer, you do additive manufacturing. If you're a hobbyist, you only 3D print.
Exactly. Back into this topic, though. I mean, how do you make sure your parts are actually good parts? Sometimes we print stuff that looks amazing, but it might just crumble in your hands. Mm-hmm. So how do we make sure that if you're selling parts to somebody, or if you're using it for applications that are a lot more intense, like in airplanes and cars, how do we make sure that's good?
Sure. So we're talking about, finished parts that are printed that could be used in a final product or in the process of making the final product that is either to spec or not to spec. Now, in large companies, what is usually the measurements? Like, how do they determine what is in spec and what is not in spec? What are the traditional methods before we go into some AI learning?
Yes, traditional methods, let's take a car company, let's say Ford. Never worked at Ford, but I'm sure this is kind of what happens on the production floor. You make a part on a lathe, for example, some type of part, doesn't matter. It comes out of the lathe. Usually there's some stations where you measure, say, the outer diameter of your parts. Is that good? Yes, it is good. It goes on down the line. Usually it comes out of a sort of like a conveyor belt. Somebody picks it up, an operator, and then it inspects it a little bit more. Is it checking for scratches? It's checking for any abnormalities in your part. Mm-hmm. If that's good, that goes on a skid, and that ships out to some other company or another Ford plant that will assemble that part into the car.
So it's a pretty big part, of the manufacturing process. Everything after manufacturing the part, becomes QA, right?
Yeah, honestly, even before that, the metal that comes into the plant that gets processed in the lathe, that has a certificate that it comes with that basically says this is the metal that you ordered to the specs that you wanted.
Okay.
All right. So that is how sort of making a part for a car would work.
Okay. So when we add AI and machine learning to this, what exactly are we saying? Like, which process? What part are we adding the AI? In terms of inspection or in terms of checking if something is within spec? Like, where does AI come in?
So let's say that that entire system that I said, it's sort of this closed loop system, almost. AI and machine learning completes that loop and actually makes it a closed loop system. So for example, if I'm making a part that needs to be 5 millimeters in diameter, and it is actually, when I measure it, it's actually 5.1. Now that information gets fed back up to the machine, and it's saying, well, if I was 0.1 over over my nominal value, I need to, machine a little bit less or a little bit more so that I can come closer to the 5.
Okay.
Right. And then, so that makes the closed loop system. Sometimes it would be something very simple, just like what I described. What's my value? Subtract that value from my nominal, and that's the modification that I have to make. But if you're introducing AI and machine learning, maybe now you're inspecting for toolware and something else that, a human or a simple machine program is not capable of doing. That will do a lot of the thinking for you so that your part is always good.
So when I'm picturing measuring a part, I'm picturing like a metal machined part. But when we say 3D printing, that's not always going to be the case. Sometimes it might be a plastic part, right? Where there are different shrinkage rates depending on what plastics there are. So how does AI learning, make that a little bit easier for us? Also, with additive manufacturing, we know that the parts that companies are making sometimes are a lot more complex than what they would normally machine, because machine process and additive is very different process. So how does the AI fit in to 3D printed parts specifically, where the complex geometry might be a little bit more hard for a human to determine if it's within spec?
For sure. So I think AI and machine learning is all about predicting things and adjusting based on that. What do you call that word? Based on that
tolerance.
Based on that tolerance or whatever the conclusion of the AI system, you adjust based on that, right? So if you're extruding something complex, let's say something like this iPad, and you want to make something on the 3D printer that resembles this, how are you going to make sure that each layer was laid out 100% correctly? How are you going to do that? Are you going to look at are you going to take pictures of every single layer, and then somebody's going to look at it and say, okay, not okay? How's that going to go? So, you introduce a camera, for example, it takes a picture, it compares it to what it's supposed to look like, and then it will make decisions based on that. So if, for example, your system or your camera starts showing things that are not supposed to be there, or, things that we can adjust for within the program, the AI or machine learning would over time, right? AI and machine learning work over time. So if you're making one part, maybe your machine learning is not that good yet. But if you made 1,000 parts, now you know that your system is good. So it will adjust properly. It would make your part either bigger, smaller. It will adjust the flow rates in the system. So your system becomes really, really complex.
So I'm starting to understand this now. So it's not only the AI can be applied to the final inspection, but it can also be applied during the process of manufacturing, additive manufacturing. And that's where it would come in when you're not going to have a human sit around and look at the layers and say, no, that layer 156 is good, 157 is good, 158 is good, 10,500 is good. That's when we're offloading this to an AI learning system so that it can do that on a continual basis.
Exactly. And it basically makes every single part that you make just a little bit better over time.
And then the feedback, when you say a closed loop system, we're going to get that feedback from the AI, and then we're going to be able to improve on the process for the next parts, and also predict the wear of the machines that we're using to print it with and manufacture it with, right? So we can predict like the nozzle is going to start wearing out after 10,000 hours. So, and we can see that deformation with machine learning, so we can preemptively change that, ahead of time.
Or, if your nozzle, maybe it does wear out after 10,000 hours, maybe the AI is so good that it will take that into consideration when making your part. So now instead of changing the nozzle every 10,000 hours, maybe the AI helps you, and now you have to change it every 20,000 hours. Maybe the AI can account for that wear for an extra 10,000 hours.
So in terms of the application of this technology, are we thinking that this would apply somewhere down the road to desktop systems or just industrial systems for the meanwhile?
Who knows? I don't think that there's any company out there that currently uses a very stringent closed loop system with AI and machine learning, all that. I think there's some steps towards that, but I think all of it is mostly research in universities like MIT, where students are like just all day long are looking at this thing. How do I make this better?
Okay. So we'll see that trickle down, research-wise. Someone will pick it up and say, hey, I can apply that to my system. And then suddenly we're going to start seeing more of this technology being implemented in the industrial consumer space.
Yes, exactly. The one thing I want to add before we move on is like the more sensors you add, the more systems you add into your 3D printing system or any manufacturing method, the more things you have to validate. The more things you have to check if they're, is my camera still working good? Is my camera taking good pictures? All of these things kind of like add up, and now you have this super complex system that you have to check all the time, because maybe your AI program is good, but the information you feed it is bad.
Right.
So how do we do that?
Right.
That's something I want to add.
Okay, well that's a lot to think about, and it's for much smarter people than us to put that together so that we can try it sometime. Let's move on to the next topic. This is going to be a hot topic that everybody keeps talking about, and it's metal 3D printing, right? I mean, we hear this all the time. Metal 3D printing, metal 3D printing. There's these materials available. There's these materials available. What's new in the industry, and what should we take note of?
The newest thing is the BSF came out with something called UltraFuse 360L.
Okay.
So that's stainless steel. You can 3D print it on any 3D printer that can 3D print up to, I think it prints at 270 or something like that.
Okay.
Right? You need a abrasive resistance nozzle, and you're good to go. So you can 3D print a green part, a metal part at home. Send it out to a company called DSH. They debind, sinter it, and send you back a 3D printed metal part. So
okay, that sounds entirely too simple. So what's the catch?
There's no catch. No, I'm joking. There's a catch. The catch is, there's some design limitations.
Okay.
And we know that any manufacturing technology has design limitations. So here, maybe the size.
Are we just talking about support? Because, we already know how to deal with support, with water-soluble support and things like that. So are we just talking about that, or is there more restrictions?
There's more restriction. Okay. There's maximum part size, that can fit in the debinding and sintering machines. There is different geometries, minimum feature sizes. It's quite a big list of design guidelines you have to follow. But generally, if you're going to be producing metal 3D printed parts, you kind of already know what you're doing.
Okay.
You're not just doing it for fun because it is a little bit on the expensive side for, hobbyists. I think the filament is around $600. Debinding and sintering per kilo is about $60.
Okay.
Plus, shipping.
That sounds pretty affordable compared to an entire 3D printing system.
For sure. Yeah. So I think, so the whole process to sinter maybe 3 kilograms is like $800, $1,000.
Okay.
Which compared to the industrial systems, you're looking at $100,000, $200,000.
Okay. So that's a big difference. So what are we losing in between those systems? Like there's obviously got to be something where there's, not just a catch, but right. What's the trade-off, for us being able to save $100,000?
I think the trade-off is the control over the process
and
the speed at which these parts are coming back to you. So DSH is doing sintering debinding cycles every 2 weeks or so.
Okay.
Right. So if you're sending a part today, it's going to get it's going to get processed twice a month. Right. So you got to make sure you're in that window. If you're perfect on your timing, you're going to get your parts back in 4 weeks. Right. So you're sending a kilogram of parts, you're getting back parts in 4 weeks. Between those 4 weeks, maybe you already had design changes, maybe you wanted to change something, maybe you need to validate something else, so you're losing a little bit of time versus those expensive systems. But
are we getting actual metal parts? Like, we're not talking about getting metal filled parts, like let's say color fab bronze, something like that, a PLA and metal powder. We're talking about we're going to get back an actual metal part.
In terms of final product, you're getting a stainless steel part.
Okay.
That you can machine, you can,
like stainless steel.
Stainless steel.
Okay.
Yeah.
That's pretty attractive.
It is. But like I said, you're losing a little bit of time going with this way. If you have the industrial systems, it's a little bit faster. You can 3D print today, debind today, and, it takes a little bit more than just today, but usually within 48 to, I think, 72 hours, you can get a metal part.
Okay, so someone out there with even a hobbyist printer, let's say they have like a Creality printer, and they put an abrasive resistant nozzle, some kind of hardened steel or ruby nozzle on it. They print the part with support or without support?
Depends. If preferably without support.
Okay, so they print a part without support. So let's say they have a part without supports, and then what is the process? What happens after they print this green part?
So they got to print, for it to make sense, you got to print at least a kilogram.
Okay.
Right. So a kilogram is...
Wait, one part has to be a kilogram, or just all the
entire
parts?
Batch.
Okay.
So whatever batch you're sending,
so
needs to be
1 kilogram per batch.
Yeah, 1 kilogram
Gotcha.
per batch. That is sort of the coupon you get. So it's for 1 kilogram. If you want to do 2 kilograms, make sure you have 2 kilograms.
Okay.
You got to get 2 coupons.
Gotcha.
If you get
so the cutoff is per kilogram.
Per kilogram.
Okay,
Exactly. So once they print it, they just send it out. They package it well because those green parts are a little bit brittle, and they get back a stainless steel part.
Okay, so what happens at DSH then?
At DSH,
it sounds like magic happens at DSH.
Magic.
Okay.
It is magic.
It's metal magic at DSH, but give me a little bit on what happens there.
Let's do it. So they get their package, they document what's in there. They send a very, very detailed report. So they document what's in there, the green parts. They say, are these parts looking good? Is the extrusion good? Is it going to be okay to put in the debinding system? Then they put in the debind system. That removes the binder, the binder that holds, the metal powder together.
And is that a chemical process?
That's a chemical process.
Okay.
Yeah, they call it catalytic debinding process. I don't know all the details in terms of chemistry, but it basically just dissolves away the binder that holds it together.
Okay.
All right. At that point, the parts are extremely brittle. They're called brown parts because they look brown.
Okay.
And then you put it in an oven, basically, where
Okay.
it centers. And then you get your stainless
And this
steel
is
part
like
of
a
it.
10,000 degree oven.
Yeah, something crazy. Yeah.
Not your typical oven.
Yeah, not just typical, making potato wedges.
Okay,
Oven, yeah.
so an industrial oven, and it centers, basically binds all of the metal particles together. And in this process, we're losing how much of the material?
Roughly 25%.
Okay.
25%, yeah.
Okay, so your part is going to shrink by approximately that amount.
Yeah,
Okay.
roughly that.
So that's something that we have to kind of think in advance and say, hey, if I want it to be, 5 centimeters under diameter, I better make it 25% bigger.
Basically.
Approximately.
Yeah.
Okay, gotcha. So that's one trade-off. I mean, it's not the worst thing, but it's certainly something that you'd have to plan.
For sure. But that happens with any 3D printing metal system.
Okay.
Right? So you're printing your parts bigger so that when they shrink, they're at least close to the size that you want.
Okay. And then in terms of specifications, and because we just talked about conformity, when we finally get the parts back, they look like metal, they feel like metal, they are stainless steel. And then you mentioned machining it as well. So that would be to bring that more into spec, or?
Yeah, so I think with 3D printing, once you get your part back, is a lot similar to forging or casting something, right? So if you're casting like engine blocks,
okay,
most of it is untouched.
Right.
But where your pistons go, we have to machine that to spec.
Right.
So that's exactly what happens here. If you need something bang on, you're going to take it to your milling or lathe machine or grinder machine, surfacing machine, whatever it is, going to process it the way you would any other part.
Okay, great. So, I mean, we're obviously not going to be able to bypass that, because then that would just take over the entire industry.
Yeah, that'd be nice though.
So it's, yeah, of course. Yeah. So we still have to do some of those traditional post-processing methods afterward to make a workable part.
Yeah.
But if it's something like an aesthetic part, or something that doesn't require the same tolerance, it's ready to go.
Yeah.
Okay. Awesome.
There you go. Yeah.
Wow, that is an amazing thing.
It's pretty cool.
So everybody can try it out there as long as they have an FFF printer and abrasive resistant nozzle.
Yep.
Okay.
Exactly.
The barrier entry has been lowered. Metal 3D printing is within reach for most people who want to try it.
Yeah. And I'm sure there's going to be more filaments coming out. Stainless is the first one, but I'm sure there's going to be other types of metals that you can use. Maybe cheaper, maybe more expensive, depending on what you want to do.
Great. Well, thank you to BASF for kind of leading the way and taking charge of that, because, it is a scary thing when we talk about metal 3D printing, because we don't know none of us have a lot of experience in that category when we are working with FDM machines. It's mainly going to be carbon fiber filled for strength, or just standard thermoplastics.
Yeah. I do want to just circle back to the support structure. So you're still able to print parts with, stainless steel supports. You're going to have to remove those for DSH.
Okay.
And what they do actually is they coat it with ceramic coating.
Okay.
So that once your part is debound and sintered, you can actually just pop that right out.
Okay,
so
it's
it's
one
supports.
extra process, but we can still use supports.
Yeah.
Almost the same traditional way that we would use that during printing.
Almost, as long as you can get to your supports. Yeah.
Right. Okay.
If you have internal cavities with supports, it's going to be.
So essentially, everybody has access to this. We just have to have a little bit more foresight and planning.
Yeah.
And then a little bit of post-processing, depending on what tolerances we're working with.
Yep.
And then you can have your metal print for not $100,000.
For not $100,000.
Okay. Yeah. Well, that's pretty exciting, and thanks for bringing that up from the industry.
Yep.
I think right now what we should do is we should talk about some of the things that we're doing, because we've talked about a lot of things that is happening in the industry, but let's talk about some of the stuff that we've been doing. We've been super busy, even though it's been COVID. We've been super busy. And some of the things that we're working on, if people have visited our site and whatnot, is the YouTube channel that we're starting to build.
Yeah, we've become stars.
Well, we're planning to, right? Not yet, but we're planning to. Depends on how many people click on that right now and subscribe. But what are we doing on this YouTube channel, and what is the motivation for that?
First of all, we're going to highlight all the stuff that we carry at Shop3D and give you a little bit more of a personal insight. We use everything that we buy, right? We use everything that we sell.
Yes.
So we have a good amount of experience with any printer, any filaments, any type of tool that we sell. We know how it works. We know the pros, we know the cons, and we're trying to communicate that over video.
Right.
A little bit of a different medium.
And the motivation for that, I'll speak to the motivation actually, is people will be surprised how many products we actually carry. We have over 700 SKUs at our shop. So there's a lot of things where people may not ever see just being on our website. Yeah. And sometimes I think because we play with almost all of those 700 products, there's a lot of cool things that people don't know about. And we find out that people don't know about when they come and visit and we talk about it and they see it on the shelf and they're like, hey, what is that? Why don't I have that? Yeah. It's always been available. It's been available for the past, 3 to 4 years, but they haven't seen it because it's kind of buried in our website because we have so many products. Mm-hmm. And now with, showroom visits being much more of a thing of the past, we're kind of choosing video as a way for us to do these interactions, even though it's not as interactive as it used to be.
You know what? It's very close.
It's pretty close, yeah. And you know what? We have a great team here doing the videos, so you're not going to get something where there's bad audio and things like that. We're trying to make it so that everybody can have that enjoyment, while virtually visiting us and seeing what we're doing at the shop. Mm-hmm. Great. Okay, so what is the last, video that we worked on that people should know about?
I think the last one was the Formlabs.
Okay.
Formlabs 3L, right?
So okay. That's the big thing. That's the big launch.
That's the big launch.
Yes.
But I think that's the last video we did, right? So
should we tell people that we actually have a 3L here now?
Definitely.
Okay.
Yeah, so we've had a 3L for a week now. Yeah, printing massive SLA parts.
Yes.
And it's very simple, right? So if you ever use the Form 3, it's exactly the same.
Yeah, there's no difference.
No difference
whatsoever. It's just bigger and heavier. Bigger. It takes more space in the showroom.
It takes more space.
But yeah, we talked about the seam during the live launch, but it's almost a non-issue when we're printing with it now.
Yeah, I mean, the initial pictures that I saw, the seam was like, I don't want to say bad, but it was there, right? And we're printing with some clear resin right now, and I tested the seam, and you got to know there's a seam to look for it.
I like to describe that seam as almost like a scar. It kind of like builds over and scars up, in a particular line. But now we're not seeing anything like that. Like if we look really closely, we were seeing like a tiny bit of like a surface finish difference.
Yeah.
But that's about it.
Yeah. I want to compare it to like if you've ever seen injection molded parts, there's sort of like this line down the middle sometimes.
Right.
And it's way less visible than that.
Right.
So if that's acceptable, these parts should be acceptable.
So one of the worries that we had was the seam. Yeah. That's no longer a worry. But tell me a little bit about print times, because we're dealing with like 5 times the build volume. So what are print times looking like?
You know what? My average print time has been long. It's been like 24, 28 hours for print.
Right.
Right. But I'm printing basically with the entire build volume. It's like 13 by... What is that now?
See, we say that's long, but if you were printing full size on the Rays or on the Ultimaker, it would exceed those times.
It would exceed those times, yeah.
Yeah. So, it's long, but it's not.
But think about the alternative that was, before the 3L, you had Form 3 or a bunch of those. And if you want to make big parts, you had to print 15 different parts and then put them together. So that time is definitely saved.
And putting things together is, although there are methods to do it now, it's worse in a seam. Let's put it that way.
Definitely. It's worse, and you're going to pull your hair.
Yeah. And honestly, if you have a lot of pieces, then you're like, is this the XY version of it? And then you start gluing things together and it's wrong. And also, how did we glue, resin parts?
That was a mission. But we used to put parts together, put a little bit of uncured resin on it, and then cure it.
So we would manually
cure our parts together.
Yeah. So I'm glad we don't have to do that too much more.
Yeah. But now people are going to complain that the Form 3L is not big enough.
Right. And then they'll need a 3XL?
Sure.
Okay.
3XL.
Okay. Well, I'll just send that comment over to Formlabs right now and just get them started on it.
Get them started.
3XL. Okay. So it sounds It sounds awesome. I've seen it. It's awesome. It's cool because when you see it print, you actually see two laser spots.
Yeah.
Go over the part at once, and they kind of converge. Depending on your shape, of course.
Mm-hmm.
But that's something that we haven't seen before. Two LPU units within the Form 3L to make these big parts.
Yeah.
What are we planning to do with our first parts that we're printing?
I'm not sure what it's going to look like at the end, but we're planning this massive crystal tree. Was it? I think this was your idea.
Crystal tree or crystal antlers. I don't want to spoil it yet in case it doesn't work out.
Yeah, but so this is one of those where the 3L is actually not big enough because we're going to join, I think it's made out of 13 parts.
Yeah,
so this is going to be
We're trying to
huge.
print it about 4 feet or 3.5 at least.
Yeah.
And it's going to span out, and we're printing it in clear resin so that we can put
some
lights
lights in
through
there,
it.
yeah.
We really want to show off big prints. I mean, when do we have the chance, right? When do we have the chance to make these giant crystalline type prints, without printing 100 parts, right?
Yeah, now we're printing just 10.
If we only had the Form 3, we would basically print rings.
Honestly, we probably wouldn't even do it.
Right.
Yeah.
Or we would have to build a structure and kind of put the parts around it, and then it wouldn't be clear the same way. So this is enabling us to do something with the easy button, essentially. And hopefully everything turns out, and we'll be able to showcase off this awesome print that we designed.
It's looking pretty good now.
Awesome. I can't wait. I have to wait because it printing those 13 parts is going to take 13 days.
Basically.
Right. Okay. But it's going to be worth it.
It will.
Okay,
awesome. And you all will be able to see it on videos. So
great. Well, I'm sure we'll do a video on that, as we're closing in and putting the parts together and assembling it. So we'll be able to share it a lot more. All right. What's next? What else should we talk about?
What else should we talk about? What other videos have we made? I think people don't know that we make videos now. So
true. Yeah. I mean, I think we did one on the Ultimaker Tough PLA. So I think that's coming out shortly. So if you sign up, you'll be able to see that one shortly. And we've also done Magigoo. We've actually done a lot. We've been really busy.
We've been busy. Yeah.
I can't wait for
check
people
it out on the YouTube channel.
Yeah, I can't wait for people to be able to start finding it. I know we're not known for video, but now we're coming in strong and hard, and we want to help people be a resource so that they can get some of these videos without spending too much time, because we're trying to plan all these videos down to less than 3 minutes, right?
Yeah.
Because we know how busy people are, and they have lots of Netflix shows to watch. So we want to make it really quick for them to get a lot of information and be entertained and not be bored.
Tell me, Ken, do we have any promotions coming up?
Promotions. We always have promotions, and sometimes we don't promote those promotions well enough because we carry 20 brands. Yeah. So sometimes we don't tell people enough about them. But let's get into some promotions because I'm sure people would be interested. First thing that's coming to my mind is Ultimaker Trade Up Program.
Right, tell me about it.
So basically, if you have an older printer, one that's broken, and you want to trade it in and get the Ultimaker top-of-the-line S5 Pro system, you're going to be able to get $500 worth of filament free with the system. And, because the material handling station on the S5 takes 6 spools, I think it equates to somewhere around 10 or 12 extra spools of material. Yeah. So that'll keep you running for days and weeks.
Oh, yeah.
Right?
Oh, yeah. Does the printer have to work?
No, it doesn't have to work.
Okay.
You just trade in whatever scrap printers you have,
cool.
and get a big discount on some filament with your Ultimaker. If you were planning on getting an Ultimaker anyway, this is a no-brainer. Idea, yeah. I know people who have printers sitting around, or you can just go to Kijiji, buy a $10 broken printer and trade it in. It's going to be worth it.
That sounds like a loophole.
Well, I'm not advocating it. I'm just saying that even if that would happen, we would probably accept it. So let's just leave it at that.
Okay.
Before I get in trouble.
What's next?
What's next? We also have. Actually, it's still Ultimaker related, but we are selling some of our demo models that we have in the shop. Yes.
Sadly.
So
taking away my toys.
And why is why are we doing that? Why are we selling some of our demo models?
Mostly to make space for all the new stuff that we got coming. It's these printers are getting bigger and bigger, and we have so many more of them now.
Yeah, we used to carry the entire lineup of Ultimaker history of printers, ranging from the original all the way to the S5, just to show kind of the evolution. But that took up an entire section, like 25% of our showroom, right? And we have all these new things coming in, and the 3L takes a lot of space on its own. So right now we definitely need to make some space, and we're also slotting a little bit of space to kind of build a set for video as well, so that we can do videos a little bit easier. So with that said, we are going to let some of our units go. So we have some home. Yeah. Okay. Home. But tell me about these models. How are they used, and what condition are they in?
So we've been using these demo models for a while now. We print sample parts for people to test out these machines. We help our clients if they need a little bit more production capacity. If they have like a big project, they don't want to buy a printer, we help them out. So that's we use the Ultimaker 2s, the 2 Pluses, the Extendeds, Ultimaker 3, even our Lulzbots. So we're putting some of those online.
Okay.
For people to maybe use at a very good price, in my opinion. And it goes through our tech team over here. It gets refurbished. We install new nozzle, belts, whatever needs to be done, we do it for you. So once you buy it, you can just use it.
And people don't know this, but Ultimaker printers pretty much last forever. Like, there's plenty of parts available, and if anything gets loud, replace it, and then it's good to go out onto the floor again.
For sure. I mean, one of the printers is the Ultimaker 2 Plus Extended. It has 13,000 hours on it.
Right.
And that one's still going really good.
Yeah, there you go. So you get a workhorse that has plenty of life left on it for quite a severe discount. I also want to talk about some other stuff. So we've talked about some deals. Let's talk about what people are seeing on our website, because we've had a lot of website changes lately. The marketing team has also been extremely busy. What are the big things on our website that people should be checking out?
So we got the Ultimaker S3. So we're getting features for the work from home program, right? So the S3 is great because it's a smaller machine, super reliable. You can print anything that you want on it, nylon, polycarbonate, nylon carbon fiber, anything. But it fits right on your desk beside your laptop, and that's great because a lot of us don't have a lot of space at home, and that's the perfect machine for
How many machines you got at home?
Too many. I have a full basement worth of machines.
Okay. So space is at a premium also at your basement.
Also in my basement.
So essentially space is at a premium everywhere. So a smaller machine definitely makes sense, if you're having it in the home, because you don't want a 3L, in the house, in the living room. But if you had an S3 in the living room, it looks cool enough.
What would your wife say if you bring a 3L home and you're like, I want to pop it right here next to TV?
She would say many things, but it might be in Vietnamese and not appropriate for all the audience. So let's keep small printers, at home, and not send engineers home with giant S5 printers and whatnot. So that makes a lot of sense. So this page is kind of catered to kind of talk about that experience of working from home. I know some of us have to do that, and it is very helpful to have a printer at home because we can have that offsite workflow as well with the rest of the team. Yep. So actually, you know what? Maybe you want to talk a little bit about that. If you were in an engineering team and you got sent home, with an S3, how would that workflow look like with the rest of your team?
So it would be pretty simple. So the S3, the Ultimaker S3 and S5, they connect to the cloud, right? Okay. So if you have a team manager, for example, you can manage what's going on with the printer, check up on them, give you permissions if you need them to print with different materials, and queue up jobs. So it's not going to be just you using the S3 at home. Somebody can send a job from somewhere else in the world. You'll print it for them, and maybe you'll test it out. Maybe this part is for you. So somebody designs it, and he's like, "Hey, Ken, can you check how this part works with the rest of your assembly?"
So if I was an engineering manager and I had a couple guys with S3s out there testing prints, testing parts, once they're done with those tests, with those prototypes, they could send me the file.
Yeah, I
print it on my own, and I can double check the fit and finish without ever meeting them.
Yeah. So it brings the entire sort of office workflow into your house.
Right.
And it makes things a lot smoother, a lot faster.
Do you think Ultimaker designed the S3 for that?
I don't know. Probably.
I don't know. Probably. I mean, they certainly didn't predict pandemic, but I guess
it works out well.
Yeah, a home office situation, makes a lot of sense.
Yeah, and it looks so good. It looks so sleek, modern.
Yeah.
It fits right in whatever office.
It's
you
kind of
put it
got that Apple type of look going for
Yeah.
it with like white LEDs and things like that.
Yeah, and that touchscreen it looks beautiful. Yeah, the
Yeah.
entire S3 system is just attractive.
Yeah.
And-
Okay. So
Yeah.
get one of these for your house, or convince your boss to get you one.
Yeah.
Okay. Before we go on to some of the some of the events that are coming up here at Shop 3D, let's talk about a non-3D printing issue that people consistently ask us about. And that is leasing and financing.
Yeah.
Our printers, when we started, our most expensive printer was around $3,000. Now our most expensive printer and systems are closer to about $15,000. So
There, yeah.
that kind of becomes not as easily affordable for the average person. So
the small business. Yeah.
Exactly, or the small business. So we have partnered with Aquasys to provide leasing options and financing options for small businesses and individuals out there. So you can apply for a lease and kind of get monthly payments to pay off for your gear. And that makes a lot of sense for businesses that are just starting to expand. If you have a printing service, or if you're a print service bureau, or if you're in a small prototyping team, you may not want to pay the full amount for that purchase, especially if you're going to try to amortize it over several years of use.
Yeah.
So accounting wise and finance wise, it makes a lot of sense to lease because you can write off almost the entire amount through your accountant. Talk to your accountant. But I think this is a very important step for us to make things affordable for, a multitude of customers out there who are looking for solutions.
For sure. Yeah. Before this, people were like, "I can't afford this. Can't buy it." But
Yeah.
now,
And then that makes you buy something that you may not necessarily want, right?
Yeah. Yeah, it really reduces your options. If maybe the Ultimaker S5 is the right fit for you, but you can only afford something else, that's cheaper and it's not going to do the job. And then you're just suffering more because you're spending more time on this machine. So it's a nice option to have.
Right.
For sure.
So that option is now out there for most of our customers, and they can actually check out our leasing page and kind of check out the monthly payments that they would pay depending on what printer systems that they would get. So we made it very easy for people to kind of think, is $300 a month over a 3-year term, viable for me, for my business? And if it is, then that's something that they can pursue. Of course, those leasing rates could actually be lower because that's based on some of the higher costs because you haven't entered any of your own credit information.
Right.
So after a credit check, it might actually be lower.
Very nice.
Great.
Very nice.
So what other exciting things are happening at Shop 3D?
Ooh, we have the BCN3D launch.
Okay.
Right,
That's coming in a couple weeks.
Couple of weeks, yeah. So BCN3D announced 3 new printers. So we have the D25, the W27, and W50. So these are just, if you know the Sigmax, the R19, those were already big. The W50 is even bigger.
Right.
It's really big. I wish I remember the size, but it was something like 16 by 13 inches by something like 20 inches tall.
And these are IDEX printers.
Yeah, and the IDEX printer, at that size, when you have an IDEX printer, which is the independent dual extrusion, it means that you have 2 heads that can move independently of each other. You can print 2 parts at the same time. And when it's a massive build plate like that, you can print big parts at the same time.
So you can print 2 big parts at the same time.
Yeah, which basically means you have 2 printers in one.
Right, okay.
While having the option to do dual extrusion.
And I know a lot of people are looking for the Epsilon because of the large x-axis, right?
Yeah.
Because it's one of the widest printers that we have.
Yeah, it is.
So we have a lot of printers that build up because you get good resolution, but sometimes you just need that x-axis to be really big so you can print longer prints that also are tall.
Yeah.
And that's something that the Epsilons will be able to provide.
Yeah, and the nice thing, the whole thing is enclosed, so you can print with the high temp materials, no problem.
Okay, so what happens in our live launch?
What happens at live launch? It's gonna be a lot like the Form 3L one, I think.
Okay.
Right, so we're gonna just talk about all the specs. Ken's gonna ask me a lot of hard questions about them.
Yes. Better study up now.
Oh yeah, and we're basically gonna go over the D25. Who is it for? Why is it good? Why you should get it or not get it? And then the W27 and the W50, same thing.
Okay, but that's not the only IDEX printer that we're launching in Q4.
It's not. We also have the Craftbot.
Okay, we're bringing the entire Craftbot line.
All of it.
Okay.
All of it. So those are still bigger printers, a little bit more affordable.
Okay.
Right?
So affordable options for IDEX
Yeah.
In Craftbot.
Still in large volume.
Still in large volume. And they're actually available now.
Awesome.
So you can get them now. We haven't done the live launch yet, but we will. There'll be some promotional activities around it because we want to make sure that we have a good launch for them as well to tell everybody about it. We want to have some time to play with it on our own. Yeah. So we have talking points. And then, so we're doing 2 live launch for IDEX printers. This is going to be the quarter of IDEX.
Yes, it will be the quarter of IDEX.
Nothing wrong with that.
Nothing wrong with that.
Great. All right. So there are some smaller things that we are bringing to the shop that people also may not have seen because there's just so much going on. But let's talk about these other things that are not entire printer line launches. What's your favorite?
My favorite tool, the really recent one that we got, is the Shapertools Origin.
Right.
So that is, if you've ever used a router, for wood, this is a CNC router.
Okay.
So what does that mean? It means that you just load in your drawing just like you would on, say, a laser cutter. And you just have to guide this router around the piece. And you don't have to be precise or anything because it will just...
So even if you have shaky hands, it's going to compensate for that.
Yeah.
Right.
And it just makes amazing parts. It's maybe like this big, it fits anywhere you want, and you pull it up when you need it.
Right.
And you can draw right on it.
And you've already done a project at home because this is why I know this is your favorite. This is why I know this is your favorite tool because you've already taken it home for a weekend. What were you doing with it?
So
what was your own project?
There were
Tell us about it.
a couple projects that I did actually. So I'm making regular CNC machines. So I used the Shaper to make some templates and make some parts for my regular CNC machine. And I also made a little bar top arcade system.
Nice.
That
Wow.
I'm gonna bring back here eventually.
That's awesome. Okay, so if you didn't have a Shapertools Origin, how would you have done that? Like, what is the process? What is the difference?
So you'd have to design it, obviously, and you would send it out to somebody that has a CNC machine.
Okay.
Yep.
Because you couldn't do it manually.
No, you could, but it takes a little bit more skill.
Right.
I'd say, woodworking is a skill.
Right.
And
so if that's not your full-time job, you
Yeah.
probably don't have the skill to manually do it.
Exactly.
Just on a whim.
Yeah,
just on a
whim.
on a home project.
I mean, it's hard to watch a YouTube video and become an expert on woodworking, right?
Right.
So the Shaper tools brings that barrier down.
So is it fair to say that here at Shop 3D we're looking for tools that basically help people do complicated things
easier
very easily?
Yeah.
Awesome. Great.
And that's exactly what we do. It's not it is for fun, but all the stuff that we have here is tools to make your life a little bit easier. So
awesome. Okay, so I want to talk about something else. I want to change the direction a little bit and talk a little bit about 3D printing again, and I want to talk about Aquasys.
Yeah.
So first of all, it's expensive.
Sure.
Why should I get it? Because it's so expensive.
Why you should get it? It works with every material.
Every material.
Basically,
polycarbonate.
Polycarbonate. Polypropylene.
Okay,
whatever
well, other supports work with polycarbonate, doesn't it?
Not really. No. So what we had before is PV and BVOH.
Okay.
Those do not work with those two.
Okay.
I've tried.
Specifically polycarbonate.
Specifically polycarbonate and
Okay.
specifically polypropylene. If you wanted to print anything that needs supports, you had to use same material supports.
Right.
And
And
polycarbonate and polypropylene sticks to each other so well.
Yeah.
Right. So you're gonna have to settle for
You have to grind it off. You have to
Yeah.
grind off the supports, and it's
Yeah.
not going to be pretty.
or just settle for some support stuck to your part.
Right.
Right. With Aquasys, you can use it like you would PVA or BVOH, right? It's
Right.
a high temperature water soluble support.
So our previous favorite was BVOH.
Yeah.
Is this going to replace our favorites, or is it in a completely different category?
I think it's in a different category,
Okay.
right? So if you were using PVA, BVOH, maybe you're printing with PLA. Sometimes you print with some nylons, stuff like that. But if the main thing you're printing with is polycarbonate, this is going to make your life a little bit easier, and it's going to open up some doors, right? You now can print more complex parts.
Okay, so for some of these specialized engineering materials, Aquasys is going to be able to solve a problem that you basically had no other choice.
Yeah, you had no other
before,
choice
right?
before.
Like it was same supports. I mean, even breakaway wasn't a complete solution.
Yeah,
right?
it wasn't really. It was,
Right.
again, you have to reach into those areas and remove the supports.
Right.
If you have
So anything with
hard-to-reach areas.
cavities,
Yeah.
is not going to be able to be viable with breakaway.
Yeah, exactly. And another thing is if you wanted to use polycarbonate and you're like, I need soluble supports, you probably settle for something like nylon.
Right.
Nylon's hygroscopic, absorbs moisture from the air, and definitely absorbs moisture from the water that you put it in. All right, so if you toss your part in a bucket of water, nylon, it will absorb all that water,
Right.
and then you get a little bit of a different nylon part.
You know what? It sounds like we could almost have enough content, because we're saying so many acronyms, right?
That's
we're
true,
saying
yeah.
PC, BBOH, like what are all these things? We should probably do a video.
I think we will.
Okay, let's do a video so
Let's
we
do
can
that.
explain the differences between all of them and why Aquasys and all the other support materials, might be good for you in terms of dual extrusion printing.
Yeah. Everything is an application. Sometimes Aquasys is the best one.
Awesome.
Yeah.
All right. So let's talk about some things that everybody can afford. Not like Aquasys, which is fairly expensive, but we recently got some new adhesion aids in the shop. These are things that you've been asking for because you've started using these materials.
Yep. So recent material that we got is the BSF Ultrafuse PPGF30, which is polypropylene with glass fibers, 30% glass fiber to be exact.
Okay.
And that thing is hard to print with.
Okay.
Mostly because it doesn't stick to your plate.
Right.
So Magigoo PPGF does exactly that. It helps you basically make sure it sticks to your plate.
Right.
Right. And we also have the PC1. PC likes to warp too.
Right.
So you just, those products are like, what, $30? Something like that. And you just smear it on.
So shout out to Magigoo for being
making that
way
stuff,
way ahead of the
Way
curve,
ahead.
right? Before we even get these materials popularized, they already have a formula to help it stick to the bed, and we know that first layer adhesion is the most important thing. With FFF printing,
we basically have a Magigoo for every material now.
I think so. Yeah. You can get the full kit, and you can get all these individuals separately if you use specifically PPGF all the time. That makes a lot of sense.
Yep.
Great. All right, so let's talk about other consumables, and then maybe we should wrap it off because it's starting to get.
It is starting to get long.
There's a lot of material.
We can talk forever.
We should probably break this up more often instead of throw all of these things at the people out there. Okay, so let's wrap things off. I'll talk about one last thing, and these are some of the new resins available for Formlabs as well. So, one of the things that I notice when Formlabs launches a new consumable, a new resin, it gets more notice than if Ultimaker launched a new material. Why is that? Why is it that unfair? Let's put it that way. Because
it's like Formlabs is leading the way in these resins. Right?
Okay.
Nobody else has these types of resins. Well, maybe some of them, but at the Formlabs level, that machine is what, $4,000. Nobody else sells these materials. You have the flexible ADA, which is a flexible resin.
And ADA means
ADA is the shore hardness, so it's
okay.
That's the flexibility of your part. You have ADA, which is the new one. You have 50A. You have some stuff in the middle as well.
So ADA is already slightly softer and more malleable than most of the TPU flexible filaments that we print on FFF printers.
Yeah, printing ADA on a FFF 3D printer is very hard.
Okay.
Just because it's so soft. I mean, it's a limitation of the technology. It is what it is, but you can do it on the Formlabs.
Right. And then you said 50A as well.
There's also Elastic 50A, which is even softer.
Okay, that feels like a gummy bear.
That's a gummy bear.
Okay.
That's a gummy bear.
That's awesome. I mean, lots of people, come to us and they say, after they print something with TPU, they say softer.
Yeah.
Softer.
So
this is a way where we can do that.
Yep. The other ones are Biomed Clear and Amber.
Okay.
I think those are also pretty
so
cool.
those are more specialized resins.
Yeah, so you need the Form 3B, which is the biocompatible one.
Okay.
And these two resins, we did a video about it. We should release it.
Okay, we'll release a video specifically about it.
Good.
But just a quick recap on those two. Biomedical.
Biomedical
right?
resin.
I mean, because of COVID, we usually never hear anything about biomedical stuff, but now it's all over the news and whatnot. So what exactly are we talking about in terms of biomedical? Are we talking?
It literally means, you can use it while doing surgeries, or you can use it for validating your products. Amber is for short-term use.
Okay.
Clear, Biomed Amber is for short-term use. Biomed Clear is for long-term use. So short-term use under 30 days. Long-term use over 30 days, right? And guess what? Some of the initial swabs for the COVID test were made out of these resins.
Awesome.
Yeah.
Okay, so that's a practical application that everybody can understand for biomedical compatible resins.
Yep.
Right. Okay. So what are the limitations to this? Because you can't just print it. I mean, it's got to be like 316L, where there's a little bit of a trade-off and a little bit of process.
For sure. I mean, the medical industry is super stringent for a good reason. So if you're going to be using this in research, I think it's not a free-for-all, but it's a little bit easier to implement.
Mm-hmm.
Then you have to validate it and so on if you wanted to use this as a product to sell to people.
Right. So if you're making a medical instrument, follow the Health Canada guides.
You follow whatever.
Just because it says biocompatible
guides.
doesn't mean the final product that you make it is.
Yeah.
Unless you follow all the rules.
Yeah.
So make sure.
And the data sheet that comes with it, it comes with it actually comes with a nice booklet about this whole thing whenever you buy a resin. So definitely read that.
Okay, so if you are in the industry, if you are helping to solve problems with COVID and you need something that makes biocompatible parts, this is now an option, and it's not that expensive, right?
No, I think it's around $500 for a liter, and you can make a lot with a liter.
Yeah,
that's right. A lot of swabs with a liter.
Yeah, exactly. That's true. Okay, so there you go. Well, okay. I think we've talked about a lot. I mean, we've been all over the map. We went to IDEX, we went to metal, we went to all that. I think we should wrap it up here for now and then come back, in a couple weeks so that we can have all new episode for everybody out there. So I hope people have enjoyed what we've talked about today. I know I had a great time.
Yeah, it was fun.
Yeah,
it was fun.
for sure.
For a first one, that was pretty good.
So we'll do this again, Felix and I, and we'll talk about more stuff. But thanks everybody for joining us, and hope you'll tune in next time.
Yeah, and feel free to call us. We have our number on our website. Use the chat. Email us.
Sometimes when people listen to podcasts, they think, these people are so far away and so unreachable. It's like, no, we're just right around the corner. Just give us a call, and you can talk to us in person.
And you can talk to us in person. If anything was interesting here and you wanted more information, just call us.
Yeah, I mean, there's a lot more to say and talk about that we're holding back. Yep. So call us and we'll unleash that on you.
Yeah.
All right.
Okay.
Signing off.
Bye.